Ayan. So, let's start. I'll start with the introduction ng assembly language programming. So, yung registers and how central processing unit or CPU works was explained by the group earlier. So, I'll start with this. So, meron tayong, audible na ba ako? Rinig ako? No. I don't think so.
Apa, ma'am.
Okay. So, meron tayong levels ng embedded programming. So, meron tayong high level, assembly language, and machine language. So, yung high level languages, yun yung mga Python, Java, JavaScript na lagi nating kinocode ngayon. So, English-like statement kasi sila. So, mas user-friendly sila gamitin. So, next is assembly language programming. So, and machine language. So, machine language, alam natin na yung computers natin can only understand 1 and zeros. So, paano nangyayari yun? So, yung CPU, it only understand high and low. So, 1 and 0. Yun yung machine language. And assembly language programming, isa tong low-level language. So, it consists of mnemonic like abbreviation and symbols. So, yun rin yung in-explain ng group 2 earlier, yung mga mnemonics like add, subtract, multiply, and divide. So, for the high level, let's compare this. So, for the machine language, it consists of binary codes. It only understands 1 and zeros. For the assembly language programming, it consists of mnemonics and abbreviation symbols. While high-level language, ito yung mga lagi natin or madalas natin ginagamit na programming languages, it contains English-like statements like class, tapos class name, di ba? Tapos, for the machine language, it is directly executed by the computer. So, since 0 and 1 sila, so directly na-execute sila sa computer since binary code. So, for the assembly language, it needs an assembler to convert assembly language into machine language. So, assembler yung tawag sa nagko-convert from assembly language into machine language programming. So, next is compiler. So, compiler yung tawag naman sa pag-convert nung nagko-convert sa high-level language code into machine language. Ayan. So, for machine language, program development is very difficult. So, for the assembly language, it is easier, syempre, than machine language. And for the high-level language, it is easier to write the program. So, makita rin natin na yung high-level language is more user-friendly. So, I have an example here ng sample code for high-level versus the assembly language programming. So, for the high-level language, alam natin sa Python, kapag mag-code ka lang ng sum or mag-add ka lang ng kunyari 5 and 2, ganito lang kasimple yung code na to. Pero sa low-level language, like assembly language programming, need mo pa siyang i-move into registers. So, yung 5, i-move natin sa EAX na register, tapos i-add natin yung 2 bago natin makuha yung sum. And then for the assembly language, so assembly language, it is a low-level programming languages. It is a processor dependent and has direct communication with the hardware. Since direct communication meaning ang mga high-level languages kasi natin ngayon like Python, Java, kino-convert siya from high-level language, yun yung mga kino-code natin, kino-convert siya ng compiler into assembly language, and from assembly language, i-convert siya into machine language ng assembler. So, 3 conversions yon. So, bale, so yung assembly language, correct, it has direct communication with the hardware. So each assembly language is specific to a particular computer architecture. Assembly language uses mnemonics to represent low-level machine instruction or tinatawag na opcodes, yung add, subtract, move, yun yung mga tinatawag na machine level instruction or opcodes. So each family of CPUs has its own set of instructions or assembly language for handling various operations. So yung example is pagkuha ng input sa mga keyboard natin. Kunyari, pag nag-type ka ng letter K, ng letter L, may corresponding assembly language code sila para maintindihan ng CPU. So, kunyari, yung simpleng pagdi-display ng information sa mga monitor natin, it has a set of instruction or assembly language code. Ayan. So, set of instruction written in assembly language are called machine language instruction. Our processor or CPU only understand, alam natin yan, machine language instruction, which is 1 or zeros. And as it said earlier, assembly code is converted into executable machine language code by a utility program referred as assembler. So, why learning assembly language is important? So, learning assembly language will help you understand how is data presented in memory and other external devices, how program interface with your operating system, processor, and BIOS, and how the processor assesses and executes instruction, how instruction access and process data, and how a program accesses external devices. So, alam natin na ang computer storage unit natin is tinatawag na bit or yun yung 1 and 0 or on and off. Tapos, yung isang byte is merong 8 bits, tama? So, yung isang byte is, yung 1 bit is base 2. So, either 0 or 1. So, 2 raised to 8 is equals to, so 2 raised to 8 is equals to 256 or 0 to 255. Kaya, yung ASCII, kung mapapansin nyo, yung ASCII table natin has 256 characters because of this one. So, each character is isang byte. So, sa isang byte, merong 256 different combinations yan. So, yung 0 to 255, ayun, meron tayo 256 ASCII codes. So, meron tong 256 ASCII codes kapag dinigin nyo dito. So, ayan. So, for the number system ng computer, so, computers natin has 4 important type of number system. So, meron tayong binary system, decimal system, octal number system, and hexadecimal number system. So, sa number system, yung decimal, so counting using fingers, base 10. So, 0 to 9. So, yung decimal is base 10. So, it counts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, for the binary, base 2. So, dalawang characters lang yon. So, it's 0 and 1. For the octal, it's base 8. So, meron tong 0 hanggang 7. And for the hexadecimal, this hexadecimal, since data is stored in bytes, so base 16 siya. So, yung, it counts from 0 to 9. Tapos, yung letter, yung number 10 niya is A, number 11 is B, hanggang F to 16. So, number 15 is F. Ayan. So, mapapansin nyo rin yan dito sa number system na to. So, meron tayong sa decimal system, ayan, so it counts from normal na integer natin. So, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, ayan. So, it increments ng 1. So, bawat ganito, so 0 plus 1, 1, plus 1, 2, plus 2, ay plus 1, 3, ayan, nag-increment lang siya ng 1. So, mapapansin nyo rin na since yung decimal system natin is base 10, so etong 0 to 9, tapos pag 9 plus 1, wala na siya. So, 9 plus 1 magiging 0, carry over 1, kaya nagiging 10. So, same lang yan as kunyari sa octal. So, sa octal natin, it counts from 0 to 7. Tama. So, after ng 7, since yung ang octal is base 8, after ng 7, 7 plus 1 is magiging 0, carry over 1. So, after ng 7, 10 na. 10, 11, 12, 13, 14, 15, 16, 17. After ng 17, magiging 20 na to. Because octal is base 8 lang. So, after ng 7, babalik siya sa 0, carry over 1. Ayan. So, same lang yan as hexadecimal system. After ng, ito ulit, yung after ng 1 to 9, number 10 is corresponding to A, 11 is B, 12 is C, 13 is D, 14 is E, then 15 is F. After ng 15, magiging 16. Paano yung count ng hexadecimal system ng 16? So it will be 1, 0. Tama? So F plus 1 is equals to, babalik ng 0, carry over 1, so magiging 10. So, makikita rin natin yan dito. So, mapapansin nyo yan here. So, same lang. Sa decimal system, same lang yan as counting numbers natin. Sa hexadecimal, after ng F, so, bale, ang nangyayari, okay, pwede tayo maggawa na example. Okay. For decimal, kunyari, decimal. So, after ng 9, pag-add tayo ng 1. Since ang increment natin, lahat ng number system is incremented by 1. Depende lang siya sa base. So, kunyari, 9 plus 1, bakit laging nagiging 10? Because, babalik siya sa 0. So, yung number natin is 0 to 9, babalik siya ng 0, tapos, i-carry over 1. Kaya nagiging 10. Same as sa hexa, ay sa octa muna, sa octal. So, after ng 7, di ba meron tayo 6, 7, 8, ayan, after ng 7, increment mo ulit ng 1. So, increment ko ng 1, hindi siya 8, kasi hindi siya decimal. So, ang octal natin is 0 to 7 lang yung count. So, magiging 7 plus 1 will be 0, carry over 1. So, same lang yan as yung hexa. So, after ng F or number 15, after ng F, so, yung F natin kasi is, eto, after ng F, mag-add tayo ng 1. So, F plus 1, magiging, babalik ulit siya sa 0. So, after ng F, babalik ulit siya sa 0, magki-carry over ng 1. So, magiging 10. So, ganun yung counting system ng decimal, ng hexa, ng octa. Ayan. So, same as binary. So, kunwari, meron tayong 001, add ka ng 1. So, yung 1 nga is ganito dapat. Ayan. So, kunyari, mag-add ka ng 1, yung magiging 00, magiging, itong dulo is magiging 0, carry over 1. Kaya magiging ganyan. So, same lang, add ka ulit ng 1. Add ulit tayo ng 0001, magiging 0, 0, 1, 1. Parang ganun. So, bale, ito is 1, ito is 2, ito is 3. Same lang to. So, kapag kinount mo rin to, this equivalent to 1, 2, 3, 4, 5, 6. Ayan. So, ayan, example ng ASCII table. Ayan, meron tayo yan. Tapos, syempre, paano natin i-convert? So, alam natin na each decimal, binary, octal, and hexadecimal system, meron siyang corresponding equivalent sa number system. Alam natin na yung, kunyari, decimal natin is, kunyari, number 6. Ang katumbas niyang binary is ito. Ang katumbas niyang octal is ito. And ang katumbas niyang hexadecimal is ito. Or example, yung decimal natin na 11, meron siyang binary system na ganito. Yung octal niya is 0013 and yung hexadecimal niya is letter B. So, paano natin i-convert yon, knowing na kunyari alam lang natin yung decimal or alam lang natin yung binary. So, meron tayong number system conversion technique. So, kapag i-convert mo yung decimal to hexadecimal, yung hexadecimal to octal, or yung octal to binary. Not sure if familiar na kayo sa conversion nitong decimal system or number system ng computer, but it is needed para makapag-start tayo to code assembly language programming. So, let me play this one. May audio ba? May audio yung...
Meron naman po.
Okay.
Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to InfoPack. In previous video, we have learned about the number system and the uses of number system, why we use the number systems. And in this video, we are going to learn about the number system conversion techniques. So let's start. First rule is, if you want to convert decimal number system to any number system, then you have to use the division method. What I said, if you want to convert any decimal number into binary, into hexa, into octal, then you have to use the division method, and we will divide the number with the base of that number in which you want to convert. Let's see an example. Consider here is a number that is 72, and this is the decimal number, and we are going to divide it with base 2, that is binary number, because we have to convert this number into binary. So after dividing this number, the result is 36 and the remainder is 0. Again we will divide it with 2 and the result is 18, remainder is 0. Again 2 9s are 18 and the remainder is 0, and 2 4s are 8 and the remainder is 1. 2 2s are 4 and the remainder is 0. 2 1s are 2 and the remainder is 0. So the answer will be, when we have to write the answer, so be careful. You have to write the direction from down to upward. If you will change the direction, then answer will be wrong. Here are the remainders and quotients and divisor. So if you want to convert any decimal number system to octal, you will divide with 8 because the base of octal is 8. Similarly, if you want to convert decimal number into hexadecimal, then you will divide it with hexa base, that is 16. So another rule is, if you want to convert any number, octal, binary, hexa, to decimal number system, then you have to use the multiplication method. If you want to go from binary to decimal, hexadecimal to binary, octal to binary, you will use the multiplication method. For example, if you want to convert binary number into decimal, then you will multiply binary number with the base of binary. 1 multiply 2 plus 1 multiply 2, and here are the weights and the result. Same like if you want to convert octal to decimal, then you have to multiply decimal number with the base of octal. And similarly, if you want to convert hexadecimal to decimal, then you have to multiply the decimal number with the base of 16. So multiply digits of number with their weights as I discussed in my previous lecture. Now the third rule is, if you want to convert any number system to any, use bit system, or first convert it into decimal and then in another system. Inshallah, we will discuss it in another lecture. So here is that picture. You can see if you want to go hexa to octal, hexadecimal to binary, and octal to binary, and binary to octal, then you have to use the bit method. Note that now decimal is not here. So that's why I have said that any to any number system. If you have to go decimal to any number system, then you have to divide it. And now if you have to go to any number system, then you will use the bit method. So let's discuss how to use bit method. So here is the table and here is the formula. How you have to make the table? You will use the power of 2, 1, 2, 4, 8. So 2 raised to power 4 is equal to 16. We are going here to write 4 variables here. 8 variables, 8 zeros and 8 1. So 8 zeros and 8 1. After these 4 zeros and 4 1, 4 zeros, 4 1. After these 2 zeros, 2 1, and up to so on. And last column you will put 0 1 0 1 0 1. So we are going to use this table to convert any number to hexa number into binary. So if you want to convert octal number, then you have to take 2 raised to power 3 because octal use 3 bits. And you will make just only these 3 columns table. So here is the number 2A that is in hexadecimal number system. How you have to convert it in binary? Here 2A. So A in hexadecimal number system means it is 10. Then the number in binary will be, we will write the binary 2 is equal to 0 0 1 0 and 10A is equal to 1 0 1 0. How? Look at table. Is there any bit equal or less than 2? Yes. Here is 2. So we will on this bit and we will off all other 4 bits or 3 bits. It's up to you which structure you are using. Now look at table. Is there any bit equal or less than 10? Because now we are going to convert another digit of hexa number to binary, that is 10. So there is no digit equal to 10 but less than, that is 8. So we will on this 8 bit 1, and now 10 minus 8 is equal to 2, and now we will on this bit, and now it is 10 in binary, that is 1 0 1 0 1 0. So here is the answer. You will write the same position of digits 2A. So here is 2, you will write binary here and A here. So here is the summary of the lecture. Up till now we have learned the conversion rules. If you want to convert decimal number into any number system, use division method. And if you want to convert any number system to decimal, use multiplication method. If you want to convert any to any number system, then you have to use the bit method or indirect method. What is indirect method? We will discuss in next video, inshallah. So, take care. Allah Hafiz.
And so, ayan, nung napanood natin yung video, tinuruan tayo ng number system conversion technique. Pero explain ko rin siya in how to convert this one. Wait, let me move. Hindi ko makita yung mouse. Kasi mouse. Anyway. Ayan. So, for example, so meron tayong 4 important types ng number system. Alam natin yan. So, we have, let me type here. Ayan. Meron tayong binary. So, meron tayong binary na base 2. Meron tayong decimal na base 10. Meron tayong octal. Octal na base 8. And meron tayong hexa. Hexa, decimal na base 16. Ayan. So, kapag i-convert natin yung, kunyari, binary to octal, to decimal, to hexadecimal, I will give some example. For example, ano bang number? 8-bit, any. 0, 0, 1, 0, maybe. Tapos, 1, 1, 0, 1. Ayan. So, kunyari, ito is base 2. Alam natin na this is base 2 or binary. Paano natin siya i-convert into octal, for example? So, kapag i-convert natin to octal, ang normally ginagawa is since octal, since i-divide mo siya sa 3. So, kailangan mo siyang hatiin sa 3. Ayan. So, yung octal, so, ang equivalent niya to octal is ito. And makikita rin natin dito yan. So, 0, 1, 0. So, meron tayong 1, 0, 1. Ang equivalent niya, ito na ang binary. Here. 0, 1, 0. It is equivalent sa number 5. Tama? So, let me go back there. So, this is equivalent to 5. And 5, kapag ginawa natin base 8. Kapag gagawin ulit naman natin siyang base 16, ang gagawin naman natin is itong binary na to, isahatiin naman natin sa 4. So, hatiin natin siya sa 4. So, ito, 1, 2, 3, 4, 1, 2, 3, 4. So, kapag gagawin naman natin siyang, decimal base, octal, hexadecimal. So, kapag gagawin natin siya sa decimal, i-divide natin siya sa 4. Tapos, bibilangin natin. So, this 0, 0, 1, 0 is equivalent to 2. Alam natin yon since this is 2. And then, 1, 1, 0, 1 is equivalent to what number? So, 1 plus 4 plus 8 is 13. 1 plus 4 plus 8, tama, is 13. So, yung 13 is, anong letter siya sa decimal, hexadecimal? So, 13. So, 10 is A, B is 11, C is 12, D is 13. Tama. So, ito yung hexadecimal or yung base 16. So, same rin siya kapag i-convert mo naman sa base 10, kung ano yung equivalent decimal number niya. So, ika-count lang rin natin siya as equivalent dito sa table na to. So, yung unang-unang number kasi dito, alam natin na 2 raised to 0, this is 2 raised to 1, this is 2 raised to 2, or equivalent nito is 1, 2, 4, 8, 16, 32, 64, and 1 to 8. Tama. So, ang ginagawa dito, kapag yung binary is ko-convert mo naman into decimal, ang gagawin mo is ika-count mo yung mga may 1. So, this is 1. 1 plus 8, 1 plus 4 is 5 plus 8. 5 plus 8 is 13. 13 plus 32, maybe 13 plus 32, 45. Ano ba? 32 at saka 13. 45. So, ito yung is base 10. So, nakita natin na from binary na meron tayo na 0010101 na base, kayang-kaya natin siya i-convert into octal. I-divide natin siya, hatiin natin siya sa 3. Magsisimula tayo sa right side. So, 1, 2, 3, hinati natin siya sa 3, hinati natin siya sa 3. Nakuha tayo ng 5 sa base. Tapos, kapag i-convert naman natin yung binary into hexadecimal, hatiin naman natin siya sa 4. So, nakuha tayo ng 2D. Tapos, same rin for this one. So, dito naman is ika-count natin yung mga naka-1 or naka-high dito sa part na to. So, not sure if familiar na rin kayo sa conversion, pero, ayan. Medyo gets itong part na to.
Opo, ma'am.
Ayan. Not sure din kung naturo na siya sa other subjects nyo. Ayan. Pero needed kasi siya as foundation ng assembly language programming. Ayan. So, kasi, bakit siya kailangan? Since etong binary, octal, decimal, hexadecimal is computer number system siya. So, number system siya ng mga computers natin. Ayan. So, mapafamiliarize din kayo kung bakit yung mga mnemonics kanina na ni-report ng group 2, merong add, subtract, tapos may addition with carry, and so on. Ayan. So, bale, I have this 100 seconds of, nakita ko lang na tutorial or introduction of how assembly language programming works. So, bago tayo mag-start and bago ko explain yung laboratory one. So, let's play this one. Ayan.
Assembly, a low-level programming language designed to simplify the instructions fed into a computer's CPU. In other words, it's a human-readable abstraction on top of machine code, so programmers don't have to manually count ones and zeros. The first assembly language was created by Kathleen Booth in 1947 for the all-purpose electronic computer. Over the next decade, it evolved into many different formats to power the supercomputers of the day, like the IBM 7090, which had a $20 million price tag.
Oops, sorry.
Assembly, a low-level programming language designed to simplify the instructions fed into a computer's CPU. In other words, it's a human-readable abstraction on top of machine code, so programmers don't have to manually count ones and zeros. The first assembly language was created by Kathleen Booth in 1947 for the all-purpose electronic computer. Over the next decade, it evolved into many different formats to power the supercomputers of the day, like the IBM 7090, which had a $20 million price tag in today's dollars. Writing code in assembly was standard until the emergence of up high-level languages like Fortran a few years later. However, assembly is still used today for direct access to the bare metal hardware and to address low-level performance issues, often on device drivers and embedded systems. And it's also used to run native software in a web browser via WebAssembly. What's tricky is that each assembly language only works on a specific CPU architecture, like ARM for Apple Silicon and Raspberry Pi, or x86 for Intel chips. To get started, you'll first need an assembler, like the NetWide assembler for x86 chips. An assembly program is divided into 3 sections. The text section contains the actual logic for the program. By convention, it contains an entry point called start, which is where the code will start executing. Next, we have the block starting symbol section, which contains variables that might change throughout the lifecycle of the app. And finally, the data section is where we can initialize constants or data that does not change. To declare a constant like a string, we start with a label, then use db for defined byte to place the hello world string into memory. By itself, it doesn't do anything, and to print it to the standard output, we will also need its length. We can use equate to convert a symbol into a constant. The $sign will subtract the current position from the hello label, providing the length of the string. And now these constants can be referenced from the start label. In the main program, each line of code contains an instruction along with one or more operands, and there are hundreds of instructions built into the language. Now, to perform operations quickly, the CPU has a limited number of registers, which are like 64-bit chunks of memory built directly into the CPU instead of the RAM. We can insert data into a register with the move instruction by providing operands for the register name and the data to store there. In this case, number 1 is used because it corresponds to system write on Linux. Next, we need to tell the system where to write, in which case we'll move 1 into the RDI register, which corresponds to the standard output in the terminal. The next register stores the message to write along with its length. Now execute the code stored in the CPU by calling the operating system kernel. Almost done, but we'll get a segmentation fault if we try to run it at this point. Update the RAX register with 60 for system exit and provide an error code of 0 for success. Now use the assembler to compile or assemble your code into an object file, then use the linker to convert it into the final executable. This has been assembly language in 100 seconds. If you want to see more short videos like this, hit the like button and subscribe. Thanks for watching, and I will see you in the next one.
Ayan. For the assembly language, for our laboratory 1, ayan, I want you to study the basic ng x86 assembly language programming. So, maraming tutorial yan. So, meron available sa YouTube, sa Google, tutorials point, anything. So, study the basic of x86 assembly language programming. Write an assembly language code and display hello world. So, ito yung introduction. So, mag-display kayo ng hello world, screenshot nyo yung code and output, tapos explain your code and how it works. So, you can explain the line one by one kung gusto nyo, and explain nyo kung ano yung compiler na ginamit nyo and paano siya nag-works. So, marami tayong available na assembler. So, meron tayong TASAM, NASAM, MASAM, and anything. Or meron na rin tayo ngayon na online assembler. So, ayan. So, ito is naka-PDF format to. So, gawa lang kay Word, screenshot nyo yung code, tapos yung output, tapos sa last part is you have to explain your code and how it works. So, I have example here. So, dati kasi before nag-aaral kami ng assembly language, ini-install pa namin yan. So, need namin mag-install ng TASAM yung gamit namin noon. Turbo yung gamit namin noon pang assembly, ng assembly language programming. So, pero ngayon, as I research, meron na tayong mga online compiler. So, you don't have to install. For example, so, meron tayong, nakita ko lang to, so meron tayong one compiler, i-click mo lang yung, itatype mo lang yung code mo, tapos run, mag-output na siya. So, maraming available online compiler, like meron tayo sa tutorials point, merong JDoodle, ayan, tapos, ito rin nag-add tayo. So, 7 plus 2, sum, ayan, anything. So, meron na silang mga readily available code. So, the catch is you have to explain how it works. So, for example, tanggalin natin to. So, hello, pwede nyong i-display na lang your name. So, your name. So, ito yung for our laboratory 1. Screenshot ko din. Send ko sa inyo. screenshot ko din. Send ko sa inyo. Ayan. So, itong laboratory 1 natin, since this is just an introduction ng assembly language and yung task lang is to display hello, tapos yung pangalan nyo. So, hello, Shirley Nicomedes or anything. Ayan. So, this will be individual. So, magsasend ako ng Google Drive link for you guys na i-drop yung laboratory 1. So, lagay ko rin pala. So, ang file name format natin is lab1 underscore last name underscore first name. First name. .pdf. Ayan. So, this will be our first laboratory. Ayan. Any question, guys? Questions?
Kailan po deadline yan, ma'am?
Since hello world lang naman siya or hello your name lang naman yung di-display, maybe, ano ba? Sige, January 11 din sa next meeting before mag-start yung next meeting natin. So, January 11 around 2 p.m. siguro, deadline. So, bibigay ko rin sa inyo yung OneDrive para i-drop yung mga assignments nyo or laboratory 1. Ayan. So, questions pa? Ayan, siguro hindi ko na rin, since hanggang 9 p.m. pa tayo, hindi naman nananagan ng oras. And para rin may time kayo to explore kung paano nag-work yung assembly language. Ayan, you can open our camera for some picture taking. Wait. Ayan. Wait. Large gallery. Open large gallery lang. Stop sharing. Wait lang. Ayan. Sige, okay na. Sige, 1, 2, 3, smile. Okay. Wait, let me screenshot this one. Ayan. Isa pa. For some, isa pa. 1, 2, 3, smile. Okay. Ayun. Thank you, guys. See you next meeting. So, group 3, please prepare.
Thank you, ma'am. Thank you po.
Salamat po, ma'am.
Thank you.
Thank you po. God bless po.
Salamat po.